So chapter 10, chapter test question 8. In here, there's a right cylindrical cup of the base 6 cm and the height is 15 cm. So this 15 cm, a lot of you thought it was the original height of the water, but please look at the diagram carefully. You can see this arrow here is pointing at from the bottom of the cup to the top of the cup, so therefore it has to be the height of the container, and in this container it contains some water. Then there is this 3 spherical stones is put inside the cup and is immersed in the water, and the water level have then rise to 14 cm. So now they ask for the original water level. So it means that originally the water level originally is here. So this is your water, and the original water level is here, so we let it as HCM. Once you put some stones into there, the water level has rise. So it becomes 14 cm now. 14 cm, and then the water level is up here. So the amount of water that has increased is actually equals to the volume of the stone, because once you put it, the water level rise. It means that the volume of water that has risen is the same as the volume of your 3 spherical stones. So here, so 3 of those. Remember, you got 3 of those. So therefore, we can say that so even though you draw it, you have to tell me that you let HCM be the original water level. Some of you give me volume, but when they say water level, they mean the height of the water. So here the total volume. So when I say total volume of the 3 stones, because a lot of you wrote 3 stones, but when you find the volume, you just give me 1 stone. So remember, the volume of the stone is a sphere. So you know how to find the volume of a sphere, but you forgot to times 3. And this volume will be equal to the water that has rise. So here, 3 of those stones, and then volume of a sphere is 4/3 times pi times the radius of the stone, which is 3 to the power of 3. And the volume of the water has rise is, so here this cup here is a cylindrical cup, so it's a cylinder shape. So cylinder, how do we find the volume of cylinder? So it's pi times r square, which is 6. The radius of the cup is 6 cm, and times the height. So the new height is 14, and we're looking for the change of the height, the water rise. So here originally is pi times 6 square times h. H is your original. So here we will have to solve it. So on the left hand side, you got 108 pi, and then you have 504 pi minus 36 pi h. So now you can solve it. You got minus 396 pi on the left hand side, minus 36 pi h on the right hand side, and when you divide the minus 396 pi with minus 36 pi, then h will be 11. And in this case, you can say that the original water level is 11 cm. So this is what they ask in part A. So always when you have this kind of questions, when they talk about the water level, something immersed into the water, so originally there's a cup of water and then you add something to it. So the volume of whatever you add should equals to the volume of the water that has rise. So make sure you understand this concept here. This is very important, this part here. So whatever you add should equals to the volume of the water that has rise. So make sure you understand this concept, then you know how to find it. Or if you can't remember this concept, at least you can show me you know how to calculate the volume of the free stones. So at least you can get some marks here. And also, please show me that you know how to find the new volume of water. Maybe because new volume of water, the information is given to you already. You got 6, you got 14, and you know that is a cylindrical cup, then you should be able to find the volume of it. So let's look at part B. Part B says if the free stones are replaced by a new spherical stone. Why do I have to emphasize this because a lot of you, when you look at this here, you thought it's replaced by 3 new spherical stones that has a radius of 4.5, but actually now, so we don't have space, so we go to the next part. So here, instead of this here, now they change it. So this is the original water, and now it add, instead of 3 spherical stones, it changed to one stone only. So this stone, the radius is 4.5, only 1 stone, so that's the difference. So now it asks you, and this stone here is immersed in the water, so will the water overflow? And explain your answer. So when it asks you will the water overflow, it means that will the water spill out? Is the water gonna spill out? And it really depends on this stone here. So if the volume of this stone is big enough, if the volume of this stone is bigger than the capacity of the cup, then it means that it is gonna overflow. So you have to try to find the volume of the new stone with the volume of the water and see whether it is bigger than the capacity of the cup. So here we have to find a few things. The volume of the water. When I say the volume of the water, I mean that the original water in here, because you got the original water, you add the stone 4.5 radius, and it becomes this one on the right hand side. So the volume of the water, so how do I know what is the volume of the water? So the only thing that has changed in this scenario is these 3 stones become 1 spherical stones. So the original water, the amount of the original water should be the same. So here we have pi, and it is still this 6 cm and not 15, but 6 cm is the radius, so we got pi r squared, and we have to times the height because it's the cylindrical cup, and the height of this water level is your original water level, which you have found in part A, which is 11. So therefore, you have 396 pi cm cubed for the volume of the water. Then you have to find the volume of this new spherical stone. So volume of new spherical stone. So this stone here again is a spear shape, so volume of it is 4/3 times pi, and the radius is 4.5 to the power of 3. So therefore, when you calculate it, will be 121.5 cm cube. Sorry, pi cm cube. So be careful, a lot of you keep the pi, but in the final answer you forgot to write pi. So this is what you got for your spherical stones and your water. So now you have to find the capacity of the cup, so that you know when you add the volume of the water and the stone, you can compare with the capacity of the cup. So we want to know how big is the cup actually. So the cup, again, it is a cylindrical cup, so it's a pi times r square, and the height of this cup is 15, so 540 pi cm cube. So now we have to compare it, and we will compare it by comparing the volume of water and the stone together. So therefore, volume of water and the new stone. So equals 396 pi plus 121.5 pi, which is 517.5 pi. And this value here is smaller than 540 pi cm cube. So therefore, the water will not overflow. So whenever it says will the water overflow, you have to compare with the capacity of the cup. If the cup can contain that amount of water and the space that the stone use, then it will not overflow. If the volume of water and the new stone together is bigger than the capacity of the cup, then it will overflow. So always look at the information. Make sure you can see that the free stone is only replaced by a new spherical stone, because a lot of you thought it is replaced by free spherical stones. And again, apart from that stones is replaced, the original water has not changed. So this height here is the original water level you have found in your part A. So make sure you know how to do this type of question. So if you still struggle with this and you